Hello class, Mr. Sutton here, and today we're going to be talking about probability of multiple events and conditional probability. So one tool we're going to use to talk about these probabilities is a two-way table. A two-way table is a way to show data for two categorical variables. So in this example, the categorical variables are the people that either like or do not like skateboards. That's one categorical variable. So they either end up in the like skateboards category or the do not like skateboards category. And then the other categorical variable is like or do not like snowmobiles. So they either like snowmobiles or do not like snowmobiles. So out of this data, there's 160 people that were surveyed. 80 of those people like both snowmobiles and skateboards. 25 like snowmobiles, do not like skateboards. 45 like skateboards, do not like snowmobiles. And then 10 do not like both. They do not like snowmobiles, do not like skateboards. So make sure you understand how to read that. You just look and see which column and row it belongs in. And then on the margins, you have your totals. So there's a total of 105 people that like snowmobiles, total of 55 people that do not like snowmobiles, total of 125 people that like skateboards, total of 35 people that do not like skateboards, and then 160 people total surveyed. So make sure you have that in your notes. Now let's go ahead and look at some probability problems. So first, we have there is a spinner with 12 equal areas numbered 1 through 12. If the spinner is spun one time, what is the probability that the result is a multiple of 6 or a multiple of 4? So for this, there's a keyword here, which is or. We want to distinguish or type of problems with and type of problems. So or means that it could be a multiple of 6, but it could also be a multiple of 4, and means it has to be both a multiple of 6 and a multiple of 4. But in this case, it could be, for example, like 6 is a multiple of 6, but not a multiple of 4. That would be a satisfying result. So what we want to do is we want to list the multiples of 6 and the multiples of 4 just to see how many satisfying results we have. So multiples of 6, multiples of 4. So multiples of 6 would be 6 and 12, and then it only goes up to 12, so that's all we have. So 6 times 1 is 6, 6 times 2 is 12, and then multiples of 4 would be 4, 8, and then 12. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. So those are the multiples of 4. So 6, 12, 4, 8, and then we already said 12 are the satisfying results here. So we have total satisfying results would be 1, 2, 3, 4. 4, 6, 8, and 12. We don't want to count 12 twice because there's only one 12 on the spinner. So that would be 4 results out of 12 possible results, which simplifies to 1/3. So satisfying outcomes over all possible outcomes. All right. Now let's go ahead and look at this one. In a certain Algebra 2 class of 25 students, 5 of them play basketball and 10 of them play baseball. There are 12 students who play neither sport. What is the probability that a student chosen randomly from the class plays both basketball and baseball. So this is an and question rather than an or question. So we want to make sure that we are counting students that are playing both basketball and baseball. And this is one that is also, we have two categories here. So we want to probably use a two-way table. So I'm going to go ahead and start setting up two-way table. So plays, I'm going to put basketball on this axis. I'm going to go ahead and pause and set up my table. All right, so the setup should look something like this. We have plays basketball, not plays basketball, plays baseball, not plays baseball, and then we have our totals and the margins. So now we can go ahead and start filling out what we know. There are 25 students total. 5 of them play basketball. So total basketball, 5. 10 of them play baseball, total basketball, 10. There are 12 students who play neither sport, so not basketball, not baseball. What is the probability that a student chosen randomly from the class plays both basketball and baseball? So we're trying to figure out what belongs here. So to do that, we want to look at our table and start filling out the other things that we can learn from this table. So if 5 of them play basketball and there are 25 of them total, that means 20 of them do not play basketball, right? If 10 of them play baseball and there are 25 of them total, that means 15 of them do not play baseball. Now that we have those totals, we can learn some more things here. So of the students who do not play baseball, 12 of them don't play basketball also, but there's 15 total that do not play baseball. So that means 3 of them have to not play baseball and play basketball, right? These have to add up, 3 plus 12 is 15. And then this column of the students that do not play basketball, 12 of them do not play baseball. There's 20 students total that do not play basketball. So that means there has to be 8 who do not play basketball but do play baseball. And then now that we have those numbers, we can see that this has to be 2 because there's a total of 5 people that play basketball. 3 of them do not play baseball. So that means 2 of them have to play baseball. 2 plus 3 equals 5. And then we want to check and make sure that adds up this way as well. 10 total people play baseball. 8 of them do not play basketball. So that means 2 of them have to play basketball. 2 plus 8 equals 10. Right? So you basically just fill in what you know from the table and then start working backwards, see what other spots you can fill in. And important to note that this is and here we're looking for. We're looking for people that play baseball and basketball. So that is this box here. If it said or, then we would only be, we would also be interested in the people that play basketball but not baseball and baseball but not basketball. So we would have 2 plus 3 plus 8, right? So there's more people in that case, but this is an and problem. So here's another one. There is a spinner with 14 equal areas, numbered 1 through 14. If the spinner is spun one time, what is the probability that the result is a multiple of 4 and a multiple of 3? So this is different than the spinner problem we did earlier. Spinner problem we did earlier was an or problem. This is an and problem. So here we have to think about the multiples of 4 and multiples of 3. But this time we only want to take the answers that they have in common. So multiples of 4 would be 4, 8, and 12. Multiples of 3 would be 3, 6, 9, and 12. So which of these results are both a multiple of 4 and a multiple of 3? That would only be 12, right? 4 is not a multiple of 3, 8 is not a multiple of 3, 3 is not a multiple of 4, 6 is not a multiple of 4, 9 is not a multiple of 4. So the only one that is a multiple of 4 and 3 is 12. So that means we only have one satisfying result out of the 14 possible results here. So that would be 1 out of 14. If this were an OR problem, we would have 4, 8, 12, 3, 6, and 9. So that would be 6 possible results out of 14, which simplifies to 3 out of 7. But this is an AND problem, so we're only taking the ones that satisfy both. All right. And then here, back to the basketball, baseball type question, except for now it's an OR problem. In a certain Algebra 2 class of 26 students, 8 of them play basketball, 11 of them play baseball. There are 6 students who play both sports. What is the probability that a student chosen randomly from class plays basketball or baseball? So I'm going to set up my table again. So table should look something like this. Plays basketball, not plays basketball. Plays baseball, not plays baseball. And then your totals. So 26 total students goes right here. 8 of them play basketball, so plays basketball 8. 11 of them play baseball, so 11 for plays baseball. And this time it says there are 6 students who play both. So both is 6 right there. That's a little different than last time. So what is the probability that a student chosen randomly from the class plays basketball or baseball? So now we want to start filling out the other things we know. If this is 6 and this is 11, this has to be 5. If this is 6 and this is 8, this has to be 2. Okay. If this is 8 and this is 26, then this has to be 18. And if this is 11 and this is 26, then this has to be 15. And then if this is 2 and this is 15, this has to be 13. And then 5 plus 13 is also 18. So that works both ways. So everything seems to add up here. So always check and make sure everything makes sense in case you messed up somewhere. So now, what is the probability that a student chosen randomly from the class plays basketball or baseball? So that is the kids who play baseball but not basketball, kids who play both, and also the kids who play basketball but not baseball. So that is 6 plus 5 plus 2, which is 13. And that is 13 satisfying results out of 26 total results, which simplifies to 1/2. Another way you could get this result is what some people want to do is they see, oh, there's 11 that play baseball, 8 that play basketball, so I just add those two numbers together. But if you do that, you get 19, which is not the same thing as 13. And the reason why is because you're counting these 6 kids that play both, you're counting them twice. So if you do that, if you do 11 plus 8, what you have to also do is you have to subtract 6. You have to subtract the overlap of counting those 6 kids twice, and then you will get 13. All right, so make sure you do that. Now let's look at some conditional probability. In a class of students, the following data table summarizes how many students play an instrument or a sport. What is the probability that a student chosen randomly from the class plays neither a sport nor an instrument? So this one is actually not conditional probability. That's the next one. So this is just probability from a two-way table. So what is the probability that a student chosen randomly from the class plays neither a sport nor an instrument? So this time they're giving you the table. So that's nice. The only thing they don't give you is the totals. So you want to fill in those yourself. So total people that play a sport would be 9 plus 3, which is 12. Total that don't play a sport, 13 plus 2 is 15. Total that play an instrument, 9 plus 13 is 22. And total that do not play an instrument, 3 plus 2 is 5. So 12 plus 15 is 27, and 22 plus 5 is also 27. So that means there's 27 total in the class. So what is the probability that a student chosen randomly from the class plays neither sport nor instrument? That would be these two students right there. So that is 2 out of 27, which does not simplify any further. So that would be your final answer there. Now this one is conditional probability. In a class of students, the following data table summarizes how many students pass a test and complete the homework due the day of the test. What is the probability that a student passed the test given that they completed the homework? So this right here is what tells us that it is conditional probability, because they are giving us a condition that is automatically true. So it's given that they completed the homework. So the students that we choose will 100% have completed the homework. We can only choose students that have completed the homework. So we can only select out of this group right here. So we are eliminating this group from our data set. We don't care about those students because we cannot select them. So what is the probability that a student passed the test given that they completed the homework? There are a total of 18 students that completed the homework. So that is the sample we are selecting out of, and 11 of those students passed the test. So 11 out of 18 is our probability, which does not simplify any further. So that is our final answer. So for conditional probability, you are selecting out of a smaller sample within the whole sample, okay? To make sure you're reading carefully to determine what smaller sample you are selecting out of. And then we have this one. The following table represents the highest educational attainment of all adult residents in a certain town. If a resident who has a master's degree is chosen at random, what is the probability that they are aged 40 through 49? Round your answer to the nearest thousandth. So if a resident who has a master's degree is chosen at random, so there's our condition right there. We are only choosing residents who have a master's degree, so we are only choosing out of this data right here. So everything else is off limits. What is the probability that they're aged 40 through 49? So that would be this data right here, this 563, because that's in the age 40 through 49 column. And that is out of the 3,663 residents that have the master's degree. So let's see, does this simplify? It says round your answer to the nearest thousandth. So they want this as a decimal approximation this time to the nearest thousandth. So that would be 0.154. Thousandth is 3 decimal places. So that would be your final answer for this one. All right, and that is my last example here. So if you have any questions, make sure you are asking for help in class, and have a good day.